Hello everyone, I, Yogendra, would like to present our study on designing the evaluation of operator-enabled interactive data exploration in VALIDE. The authors of this paper are Yogendra Patil and Sihem Amekhaya, associated with Sinaches Institute in France, and Srividya Subramanian from Max Planck Institute for Astrophysics in Germany. Interactive Data Exploration Systems, or simply IDE, allows user to perform data exploration. Currently, there exists no evaluation framework for operator-enabled IDE systems. Previous works either lock user actions implicitly to compute quantitative metrics or run user studies to collect explicit feedback. Hence, there is a need for a framework that collects and compares quantitative human feedback along with system and data-centric evaluations. Therefore, in this presentation, we develop VALIDE, a unified framework consisting of methodology and metrics for IDE systems. VALIDE, which stems from evaluation of IDE system, investigates three key dimensions using dedicated metrics, which are data metric, which quantifies the closeness of user-discovered or system-recommended dataset to a ground truth; system metric, which quantifies the performance of the front end and back end of an ID system; and finally, human metric that characterizes the human interaction with ID system and consists of human system interaction, or simply HSI, which can quantify, for example, the time spent by a user to complete a data exploration task, and the human self-evaluation metric, or simply HSE, which, for example, can quantify the feeling of accomplishment reported by the user on 5-point Likert scale. To summarize our VALIDE framework, it consists of designing use cases, then assigning participants to various groups, then deriving various metrics, and finally analyzing these derived metrics. The first step in VALIDE framework consists of designing the use cases. The training use case allows participants to get familiarized with the IDE system. The test use case requires participants to perform an IDE task without external assistance. However, it should be noted that the training use case and the test use case must be mutually exclusive and commonly observe real-world scenarios. The second step involves designing the study. This step involves deciding the study procedure, whether between subjects or within subjects, the factor involved. This basically depends upon the hypothesis put forward by the developers, and finally, the labels for the factors. The third step involves deriving the HSA matrix and deriving the data system and HSI matrix. The HSA matrix can be derived using the NASA TLX form, whereas the HSI, the data, and the system matrix can be derived from the log user data. The fourth step involves analysis of data system and HSI matrix. For data system and HSI matrix, since the values are continuous, a two-way ANOVA significant test is utilized to check if there is a difference in sample means across all groups. Then, a Tukey honestly significant difference test is applied to find out pairwise statistical significance. For analysis of HSI matrix, since the response is categorical variable, a Kruskal-Wallis significant test is used to check if there is a difference in sample means for responses across group. Then, the Wilcoxon rank sum test is applied to compute the pairwise statistical significance. Now, to test the applicability of VALIDE framework, we apply it to an IE system called DORA the Explorer, designed for exploration of SDSS Galaxy dataset. DORA the Explorer is equipped with 4 data exploration operators, namely byfacet that finds subset with distinct attribute values, by superset that expand input galaxy dataset, by neighbors that find galaxy dataset with immediately lower and higher densities, and finally the operator by distribution that find galaxy dataset with similar value distribution. Now applying the step 1 of valid for Dora the Explorer, the training use case consists of pointed shape located far away from Earth and emitting light in visible and near infrared wavelength galaxies. The image for pointed shape galaxy looks like, and the corresponding SQL query to find the pointed shape galaxy looks like. Similarly, the test use case, we consider galaxies which are edge on spiral shape located nearby and emitting light in visible and near infrared range. The images for edge on spiral shaped galaxy looks like, and the corresponding SQL query to find the edge on spiral shaped galaxy is. Note that these SQL queries are created by the expert who is well versed with the SDSS dataset. Also note that the test use case consists of 7 clauses and attributes. The step 2 involves deriving the factors and their corresponding labels. Since the developer designed Dora such that it consists of new operators and improved data exploration effort of the users, we derive factors such as operators with label, all operators, and traditional operators, and factor interaction that consist of labels min and max as described in table 2. Finally, each recruited participant is assigned to a group as shown in table 3 that consists of these factor levels using stratified sampling technique. The step 3 includes deriving HSC metrics using NASA TLX questionnaire that consists of asking questions related to participants' feeling of accomplishment, effort required, mental demand, perceived control, and temporal demand. Each question in NASA TLX allows to derive HSC metrics on Likert scale between 1 as favorable and 5 as unfavorable. Also, step 3 includes deriving data system and HSI metrics such as length of pipeline, total exploration duration, average time step, and data and system metrics such as recall rate, precision rate, and average query delay. It should be noted that the goal for deriving HSC metrics along with data system and HSI metric is to cross-compare and derive correct conclusions. Finally, the step 4 includes first, analysis of HSC metrics. A Kruskal-Wallis significant test indicated a significant effect only for question 1 of NASA TLX questionnaire, that is feeling of accomplishment. A pairwise comparison between group responses for question 1 using a Wilcoxon rank sum test indicated that the significant differences mainly appears when the group participant use all operators. Then the analysis of HSI data and system metrics revealed that there was statistically significant difference in mean values of recall rate only when levels of factor operators were varied. Cross-checking this with HSC metrics question 1, that is feeling of accomplishment, does confirm that all operators does in fact assist in higher recovery of target data. Further analysis on other metrics indicated that there was no significant effect observed except for length of pipeline. The Tukey's HSD post-hoc test indicated statistically significant difference and revealed that 2 extra operators were used by participants who were assigned to groups having total interaction as max. However, cross-comparing results of HSI metrics, that is length of pipeline, with HSC metrics, effort required, there appears to be a discord between the two. One reason for this discord between effort required and its corresponding HSI metrics length of pipeline is due to the fact that the difference is small enough not to be recognizable by the participants. Hence, to conclude our presentation, we developed VALIDE, a human-centric evaluation framework for operator-enabled IDE system. VALIDE allowed to understand some inherent limitations in gathering and relying on user feedback. Application of factorial design along with statistical tests allowed us to conclude sound results. The evaluation of VALIDE opened to 2 new directions: extending Dora the Explorer with user intervention to modify operators and support new visualizations. The future goals are directed towards testing the applicability of valid on different IDA systems. Thank you for listening.